This presentation is designed to provide some basic information on sugar beet fertility. Although it won't be an exhaustive discussion on how to grow sugar beets, it does provide information on some basic concepts of sugar beet crop nutrition and how agriculture liquid fertilizer products can be effective tools to produce high-quality sugar beets. Understanding soil test analysis and consideration of specific crop nutrient needs will be discussed. It is important to remember that the goal of sugar beet production is to get the highest amount of recoverable sugar per acre. That requires a high sugar beet root yield that is high in sucrose content. However, high sugar beet root yield doesn't necessarily correspond to high sucrose content. Fertilizer management, especially nitrogen, plays an important role in that balance. Nitrogen fertilizer needs will be discussed later in the presentation, but it is important to understand that all the topics discussed here are intended to lead to that final goal of recoverable sugar. As with all crops, soil testing is one of the best tools to help make sugar beet nutrient decisions. The soil test report allows the grower to see what condition the soil is in and what is needed to correct any deficiencies. That is important not only for sugar beets, but for all crops in the rotation. It also provides the basis for developing a sugar beet nutrition program for the current year. Cation exchange capacity measures the soil's ability to hold nutrients such as potassium, magnesium, and calcium, as well as other positively charged ions such as sodium and hydrogen. The CEC of a soil is dependent upon the amounts and types of clay materials and organic matter present. Although CEC is a soil characteristic that cannot readily be changed, at least in the short term, it is a value that helps understand the texture of the soil and helps in making plant nutrition decisions. Organic matter plays an important role in the overall productivity of a soil. Generally, the higher the organic matter that a soil has, the more nutrient and water holding capacity it has, and the greater the microbial activity there is in the soil. Soil organic matter also influences the activity of many crop protection products. The use rates of many pesticides are influenced by organic matter content. It is important to know the organic matter level in a given soil and adjust pesticide application rates according to organic matter restrictions on the pesticide label. A soil pH of 6.3 to 6.8 is optimum for sugar beet production. Soil pH above 6.5 can reduce the impact of several soil-borne diseases. Soil pH also plays an important part in persistence of many herbicides in the soil, and rotational crop restrictions on many herbicide labels are based, at least in part, on soil pH. Sugar beets are sensitive to many corn, soybean, and dry bean herbicides, so it is important to maintain soil pH levels that reduce herbicide persistence and risk of carryover injury. As always, read, understand, and follow label directions of all pesticides. The soil test report shows another important factor in obtaining and maintaining a healthy productive soil, the percent base saturation. Base saturation is the relationship between the amount of calcium, magnesium, potassium, sodium, and hydrogen that is present in the soil. The optimum range for those cations are listed on this slide. When one or more nutrients are present above or below the optimal range, it has an effect on the availability or efficiency of other nutrients and inhibits the microbial activity in the soil. Calcium and magnesium, in addition to their plant nutrient value, are important to water holding capacity and drainage. If calcium levels fall below 60 or magnesium level is greater than 20, the soil tends to tighten and root development and water drainage are negatively affected. When base saturation percentages of calcium, magnesium, or potassium need to be adjusted, there may be a need for lime, gypsum, and/or potash as soil amendments. If calcium is needed but not magnesium, choose calcitic lime. If magnesium is also needed, a dolomitic lime should be used. Calcitic and dolomitic lime have a direct effect on soil pH. If calcium is not needed and magnesium needs to be reduced, gypsum is a good choice for that situation. Note that gypsum has no direct effect on soil pH. In soils that have a pH below or above the optimum range, addressing base saturation will usually adjust soil pH to that optimum range. Remember that the goal of sugar beet production is to harvest as much sugar as possible. Nitrogen management is the most important consideration in producing sugar. Addition of nitrogen will increase both beet tonnage and sugar yield, but only to a point. Too much nitrogen will increase tonnage but reduce sugar content percentage and recoverable sucrose. The table shown here is an example of how excessive nitrogen levels can actually reduce recoverable sugar. The conditions of this experiment showed that an optimum range of nitrogen of 100 pounds per acre. Sugar beets grown under different conditions will have a different optimum nitrogen rate. Proper nitrogen nutrition in sugar beet production is crucial. Lack of nitrogen will result in significant reductions in root yields, while excess nitrogen will promote significant decreases in sucrose content of the root and excessive leaf growth. The goal of nitrogen management in sugar beets is to supply enough nitrogen during the beginning and middle part of the growing season to ensure optimal crop growth and canopy development, and to exhaust soil nitrogen reserves toward the end of the growing season to obtain optimal crop quality. It takes about 9 pounds of nitrogen per acre to produce 1 ton of harvestable sugar beet roots. That amount of nitrogen can be supplied by residual soil nitrogen, credits from previous crop, and organic matter. The remainder will need to be supplied through applied nitrogen. Nitrogen recommendations are based on expected yield or yield goal for a field. Setting a realistic yield goal is very important in determining nitrogen needs. Unrealistically high yield goals will result in excess nitrogen application and potentially reduce recoverable sucrose yield. Agro-Culture Liquid Fertilizers has been doing fertilizer research on sugar beets at the North Central Research Station for over 20 years. That research has proven high energy N to be an excellent nitrogen source for sugar beet production. High energy N has been shown to provide better nutritional value to sugar beets than conventional nitrogen products and can be accomplished at 60 to 70% of the application volume of conventional sources. For growers that want to use conventional UAN products, Agro-Culture Liquid Fertilizers research has demonstrated that adding Enhance to those UAN products make nitrogen more usable in the plant and improves beet yield compared to conventional UAN sources alone. Both high energy N and Enhance contain sulfur, another important nutrient for sugar beet production. If soil tests indicate the need for more than about 3 pounds of sulfur, the product Access is an excellent sulfur source for sugar beet. After nitrogen, phosphorus and potassium are the most yield-effective nutrients for sugar beets. Sugar beets remove about 1.3 pounds of P2O5 and 3.3 pounds of K2O per ton of beets produced. Phosphorus and potassium fertility program should strive to meet at least those minimum needs. If the soil is high in either of those nutrients, applying a minimum amount of those nutrients as a starter will help get the crop established, and then the crop can utilize the nutrients in the soil. In addition to research at the North Central Research Station, Agro-Culture Liquid Fertilizers works with sugar companies and contract researchers to determine the performance of agro-liquid products. The trial shown here was conducted by Spreckels Sugar Company in Brawley, California. The results clearly demonstrate that ProGerminator, Sure-K, and Micro 500 are more effective than conventional products in providing increased sugar beet yields and sugar yields when applied through the planter. Sugar beets require micronutrients for yield and high-quality sugar beets. They are sensitive to many micronutrient deficiencies. Sugar beets respond to two micronutrients in particular, boron and manganese. They also respond to applications of copper and zinc if levels in those nutrients in the soil are low. Micronutrients are generally most effective when applied to the soil at planting. Micro 500 has both boron and manganese, as well as iron, copper, and zinc in the formulation that makes those nutrients readily available to the crop. Agro-Culture Liquid Fertilizers also offers individual micronutrient products to address specific plant nutrition needs. Use soil test information to determine what micronutrients are needed in a particular field. It is best to build a nutrient program that addresses the plant's needs through soil fertilizer applications. However, there are often occasions when specific nutrition needs can be supplied through foliar applications. Agro-Culture Liquid Fertilizer has a suite of nitrogen, potassium, phosphorus, sulfur, calcium, and micronutrients that can be applied as foliar treatments to meet specific needs. N-Response and Fertirain were developed specifically for use as foliar products, but they, along with the other products listed here, can be used as soil applications or as foliar applications. A sugar beet fertilizer program should strive to achieve the highest amount of recoverable sugar per acre. That requires beet tonnage, but more tons of beet roots do not necessarily translate into recoverable sugar. Nitrogen fertilization is the most important part of obtaining optimum recoverable sugar. As with all crops, maintaining a healthy, productive soil that has balanced nutrition will provide the best environment to grow a healthy, high-yielding crop. Maintaining proper base saturation levels in the soil will set a foundation for a healthy, productive soil. Agro-Culture Liquid Fertilizers has a suite of products to provide nutrition to the sugar beet crop. Our nitrogen, phosphorus, potassium, sulfur, calcium, and micronutrient products have been tested on sugar beets for over 20 years and have been proven to provide excellent sugar beet nutrition. Several important topics regarding sugar beet fertility have been reviewed during this presentation. Talk with your Agro-Culture Liquid Fertilizer representative for guidance in developing an effective crop nutrition plan for sugar beets. However, this has not been an exhaustive discussion on sugar beet production, and there are many other management topics that need to be addressed when growing high-quality sugar beets. Information on specific topics are also available from sugar company representatives and university extension professionals.